Can we start? Start? Okay. I'll start the recording as well. I think everything is running fine. Just need to take care of this. All right, all set. Cool. Let's get started. Welcome everyone to this Fabric meetup, and we really appreciate you coming here in person. So thanks for joining us. So as you know, that today's talk is like building universal apps with Expo. We have a bunch of sections lined up, so I hope you enjoy the talk and you at least gather some insights for you to get motivated and then try out the whole universal app system on your local machine. So that's the aim. So let's see how it goes. Just a second. A short intro about myself. I'm Swapneel. I've been a front-end developer all my career and just working on the UI side of things since last 13 years. So I've been here around since there were no frameworks when we were building web applications, and now here we are, right? So we have certain frameworks which help us build apps across different platforms. So that's the topic for today. Now before we kick off, right, I just need a show of hands of who all are developers in this room. Developers? Okay, yeah, we know. And who has worked on React Native, Expo? All right, awesome. We have people with experiences, that would be interesting. And who has worked on Next.js applications? Okay. Awesome. All right. This is just for me so that I'm aware like who's there in the room, right? All right. Let's get started. So what are universal apps? Okay. So a very quick introduction. So universal apps, it's kind of an architectural pattern, right? Which you choose when you want to build applications for multiple platforms, but then you use a single shared code base because of any number of reasons, right? So what are those reasons? How do you what challenges do we face? What factors do you need to consider? We'll take up that later in the session. But then this is a very quick intro, right? And then why is this architectural pattern so much popular? This is because first of all, you just have one code base to manage, right? So technically, it takes less time to build those applications across platforms. It's faster time to market. It's cost effective, and for a long run, you don't have to maintain 3 separate source codes for that, right? So it's pretty much straightforward. And then these are the very, very much popular use cases that we have seen where people choose this architectural pattern, right? So you have business portals. We have seen apps for e-commerce as well, being universal because the overall experience is pretty much consistent, right? Across platforms. You need the same setup to be running on Android, iOS, web, even other platforms for some places. And then you have content platforms and then productivity tools. Moving on, when we speak about universal apps, right? So broadly it can be categorized into two of them, right? So one is the actual cross-platform apps and one is hybrid applications. Now, what is the difference between these two? So cross-platform apps, these are the apps which are actually natively compiled along with your source code, right? And then there are hybrid apps which basically still run part of your web code, but they run within a web view, which is like an app shell within your native app, right? And again, you might have already recognized the potential problems or side effects because of that. So performance wise, it totally depends on what you are rendering inside those web views, because it will vary based on what devices people use, right? And the other thing is the look and feel. It's very difficult to have that similar look and feel if you are using a web view and then trying to mimic a native kind of a feel, right? But it depends on your use case. Again, people still go with this web view kind of a thing because it fits their use case. So there's no right or wrong. It just as long as you know the trade-offs, right? You choose the right platform. Now for our talk, we are just going to talk about the native side of things, which is cross-platform apps, right? Which are natively built. Okay. Now these are some of the popular frameworks. Most of you know about these frameworks, right? So right off the bat, you have React Native, which uses React under the hood. So you share the whole React ecosystem. And then of course you have Flutter, which does an equally competent job of building native applications, right? It uses Dart under the hood. Then you have Ionic. People who have worked on Angular might know Ionic framework, right? Now Ionic has come up with this capacitor runtime, which basically just takes your whole web framework or any code that you write. So it can be a Vue.js app, it can be a React app or an Angular app. You merge it with the capacitor runtime and you just have a native app running. This is pretty cool. I mean, this should have a session on its own, but then you folks should check it out. It's pretty good. And then you have Xamarin, which is just there. So I mean, you know, most of you know, right? Xamarin has been there from a long time, but there are certain side effects. They were one of the first people who started this whole universal app thing, right? Cross-platform frameworks. But then due to a specific niche skill sets required to build that app in the first place. So if you want to build a web app or a Android app or an iOS app, you first have to learn .NET and C#, right? Only then you can start building apps for 3 platforms. So it's still there. People still use it. It's going good. But now the difference between Xamarin and all these 3 frameworks is all 3 frameworks support a universal mode, which is like you can write one app and one component and it will just work out of the box in all the platforms that you support, mainly web and the native platforms, right? Now for this talk we'll be of course just focusing on React Native and Expo. Now for those of you who don't know what Expo is like a ecosystem of tools and services and convenience features which you use alongside React Native, okay? And then build your cross-platform app or just build a native app however you want to. But then it's kind of a, you know, if you do a loose comparison, what Next.js is to React is what Expo is to React Native, right? So it's just a wrapper on top, as well as it gives you a whole lot of features which we'll go through one by one. Okay. Now again, if you want to compare what does Expo handle for you, right? So if you want to build a very much bare native React Native application, so you have to have basic knowledge of React Native. You need to understand Xcode, your Android Studio. You need to set up your emulators, simulators, and other things, right? Even for native deployment, you have to take care of your environment configuration, your build and release management, etc. Now, if you use Expo, right, and all of its suite of services, this is what Expo manages for you, right? So if you want to use Expo as a part of your development for whatever reason, you can just go ahead and pay for Expo. Expo has these set of freemium services, okay? This is like the part of Expo is very, very much free. You can just use it and build your applications and then deploy it on your own infra, which also we'll go through later. But then there are a set of services which are paid, like if you want to build your native app, right, and you don't have an infra or you don't have a pipeline, you can just simply tell Expo to build it, and Expo will build it in its own cloud servers, right? So things like that. So in a way, Expo covers a lot of things for you, just like what Next.js does for you. Now, let's say you folks want to build a universal app, right? Let's say there is a use case where the client wants you to build an app which works on native as well as web, but then there are certain factors like you don't have your own infra, or you the use case that you're using, right? It's actually a good use case for building that app. So you'll have to, before you make that decision, right? Like the business can officially say, right, let's cut down the costs, but then you have to do a tech analysis and see what fits your actual use case. So this is exactly what we are going to do. So for that, right, we will take a very small use case, which is the banking app use case. Okay, now this might not be the relevant universal app example, but then still let's go ahead with it. Okay, so what we have done is we have this Aussie Bank app, okay, and we have these 3 features, right? So we have a scan and pay, we can view our account balance, and then you can also search for ATMs and nearby stores, right? Now this app has to work on iOS, Android and web, right? Now in order to make this app work, there are some technical aspects that we need to look at, right? So if you dig down into the actual coding side of things, right? So all these essential aspects of the development you need to take care of, at least analyze before you take that informed decision, right? So you need to understand how the local setup will work, your state management, what UI component library you are going to use, because it's a universal app, right? You need the library to work on your native plus web, right? And then how will the authentication work, the routing, REST APIs and other things. And on top of that, you also have some non-functional requirements, right? Where you need to consider the performance of your app, how the app is going to get deployed, if there is any internationalization required, logging, analytics, and other things. Now, what we'll do in the rest of the session, right? So we'll go through each and every aspect, at least for the technical, for the functional side of things, and then see how Expo helps us to solve these use cases, right? And what is it where we have to take care of things manually, and Expo doesn't help us at all, right? But then there are other options available. Now let's take a look at the first basic setup, right? So you want to set up a universal scaffolding on your local machine, okay? So you need machine setups, you need simulators, emulators, you need dev server, you need to build your apps locally as well, right, to test it out. Now what Expo gives us is these 4 main things with which you can start building your app immediately. You don't even require, like things to be manually set up. So first and foremost, it's the Expo dev server, right? So it's just like a web server that you use, but then once you set up your Expo scaffolding, you start your dev server and it will run your Android app, your native app and your web app at once within one terminal, right? So this is pretty handy. We'll go through that later. The other thing you get is the Expo application services, right, which is the EAS CLI command. So this command line tool helps you to build your apps locally. It also helps you to deploy from your local machine, but then you can at least use it and test out your apps, figure out all the environment configuration is done before you actually deploy stuff on your pipeline, on your actual app stores and play stores. Then the third one is the interesting part, right? This is the Expo Go application. Now this is a free app provided by Expo, which is available on Play Store and App Store. You can just download the app on your whatever Android or iOS device, and then you just use that to do your local development. You don't have to get a physical device, you don't have to have a proper test device or anything. It can be any device, and this just like when you use Expo Go to build your applications on local, it just works like a dev server app, right? So you can literally, it does refresh, it uses fast refresh, everything that you do on web, it's there on the Expo Go app. And the fourth one that you see here is, it's an extension of the Expo Go app itself. Now this is used when you have some native code, right, which you write, a custom native code, which that Expo Go app does not support. So in that you have to extend this app, then install this app on your physical device and then use it similar like an Expo Go app. So we'll go through this later, but then essentially these are some very mature tool chain items available for you to immediately get started with Expo. Right, this is how the dev server looks like. After you are done scaffolding your Expo app, right, using like default npx command, and you just start your server, the dev server looks like this, and then it has options for you to open up simulator on Android, iOS simulator, Android emulator, and you also see the web version out, right? So it just spins up a local server for you, and then there are other things as well, which again we'll look at later. Now, once your scaffolding is done, right, this is just an example that I've added. for people who don't know. So this is how you write a React Native component, right? So it's a pretty simple React based syntax. You import a bunch of things from React Native, you render a component. Here we have rendered a text component, and you do styling using this object-based styling. That's how React Native styling works. Now, once you do that, you'll immediately start seeing the output for all the three platforms. Real time, it will have hot reloading, actually it has fast refresh, which is like built on top of hot reloading. And then you just build it like a simple web application, and it's pretty simple. So it takes care of your developer experience. You don't have to worry about configuration sets, etc. You can also inspect these things on native as well as web, which we'll again go through later. Now, as I said, right, Expo Go app. So the way this works is basically you download and install this app on your phone, and then the dev server that you saw, if I go back, this is the QR code that you get, right? So you just scan the QR code with your Expo Go application, and then it just streams your local dev server setup into that Expo Go app. So the app feels like you are building your own app. So that whole Expo Go app is just like a shell app for you, and it makes things so much easy for you to build and just look at your phone and see is that component being properly rendered, how your logic is working. So Expo has taken care about this pretty nicely. And then the dev client, which I talked about, right? So it's a pretty much same thing. Now, because you are extending the Expo Go app, you have to manually install this app on your device. You can't download stuff on Play Store and App Store, right? Because this is a local build that you will be creating on your app. But this is pretty handy when your use case gets to a level where you have to write some native modules or custom modules, and then still Expo gives you this way so that it doesn't want you to go away from the actual development experience. So this is pretty handy. If you see the reviews, right, people have liked this a lot. All right, and then the EAS CLI command that I spoke about, right? So these are some very simple commands with apps, like the commands to build iOS and Android. All right, so next is UI component library. Okay, so this is the another aspect that you have to take care of. Now, ideally you want, as I said earlier, right, ideally you want to have a cross-platform compatible component library. You don't want to end up writing separate components for web and Android and iOS. And then you could need theming support, right? And then customization. By customization, I mean here is basically whatever framework you pick up off the shelf, you should be able to customize it enough based on your designs and whatever layouts or accessibility requirements. Now, luckily, we have some very mature universal app frameworks which are out there, which you can straight away get and start using, right? So you have this Tamagui, which is what we have used for our demo app, and then there is GlueStack UI, which is a pretty good universal library. And then like what they have done is they have recently introduced a V2 version of this library. You must have heard about native base. There was a universal library which was like around 3 years ago. So that whole library is going on an overhaul, and then this is the new version out of it. It's pretty interesting what they are doing. Then the third one is Native Wind, which I guess is pretty much familiar. You must have heard about Tailwind, right? So it's the native version of Tailwind. So people who are fan of Tailwind type CSS styling, they can still use the same experience and get class-based styling for the native apps as well. And then finally you have React Native Elements, which has been there from a while, right? So its popularity is also pretty good. The good thing is all of these frameworks support universal components. So you can just pick and choose from their documentation, and then it just works directly. Now, since we have used Tamagui, right? This is a very simple example of how we are using Tamagui in our demo application. And you can see on line number 17, that's the button, right? It's just like a simple button. But if you see line number 3, we are importing it from the Tamagui package, right? And if you see the output on the left hand side, it's the exact same button that will render on all the 3 platforms, right? Yeah, so this is the example. This is the actual screenshot from the demo app, which we'll share shortly. But yeah, it just renders directly. You don't even have to look at it after once you have configured stuff, right? So it's bound to work as you expect it. Okay, next is routing and navigation. All right, so again, similar to UI component library, you would want your routes to be very much common, right, across different platforms, right? Even for navigation, you would expect to have one universal API. If you want to push a route, if you want to pop a route, the same like a web behavior interface, right? Then you would also want to support some native navigation features, right, which is tag-based and tab-based navigation. So all the modern apps that you use, it has tabs on the bottom, right? And then once you click on that tab, the content is loaded. You can play around with that content. You can dig deep into different levels within that same tab, right? And then when you switch to a different tab and then come back to the same tab again, the history still stays, right? So it's a nested stack history. So that's a very common routing feature which mobile apps provide, right? That's not available on web, but then how will you deal with this, right? So you need to, ideally you would want one library which would support all these features, right? And then of course you need animated transitions, otherwise the app would look just like a bare minimum setup. So of course production ready apps needs animation. So luckily Expo gives us this routing library, which is the Expo router library. If you might have used React router or Next.js router, right? It's similar to that. They have just followed the same API mechanism. You get all the features, file-based routing. It supports your stack view and tab view as well, which is also supported on web side of things, which is pretty interesting. So the Expo router does all the heavy lifting. You just have to play around with the routes and set up your routes in a way that your history and everything works, right? Then you have a single API. If you want to move ahead, move behind, you have HTML elements for links, etc. And then finally, because it's a universal app, when your final web bundle is built, right, you need to have route-based chunks, you need to have tree shaking and everything, right? So all of that is already inbuilt within the web bundle. So you don't have to manually add stuff. All right, next is authentication. Now authentication, again, it really depends on your use case. The use case that we have, it requires all types of authentication, right? So you need your actual sign-in flow. Sign up we might not need for like banking apps, but then sign-in flow you need it. You need multi-factor authentication. You also need biometrics, which is an additional authentication on top of everything, right? Now it might be the use case for your apps as well. Now the way Expo helps us here, right? Expo provides a Expo auth session library. Okay. Now this library, this works for authentication flows where you have a OAuth based authentication, right? So it's a browser based authentication. You just chuck in this library and then set up your OAuth credentials and everything works as expected. Similar to web, it's a web based authentication at core, right? So it works on web and native both, and then that's it. It handles everything. And if you go to the Expo docs, there are several guides for popular OAuth providers, right? You can just go and see how is the implementation, copy paste the code and get it running. It's pretty straightforward. Then you have something called as Expo local authentication, right? So this is the biometrics support that you can add in your Expo app. And as the name suggests, right, this is a local authentication. So it doesn't do any, so it's an addition. It uses your device-based biometrics, fingerprints or pins or whatever face recognition that you use, and the data never leaves your device. That's the best thing. Okay. Now, sadly, this is only for native because that's how the protocol works, right? For the biometrics for at least native apps. Now, when you want to do it for web, you must have heard about web authentication, right? This is now the new way of passwordless authentication. So you must have logged in via Google and use those pass keys, pass phrases, right? Which is like you just put your fingerprint. So you will need to implement this separately from your native app. So this is where your code splits. Okay, currently there is no universal way of handling this, but then it, like, the way you can split the code is pretty straightforward. You just do stuff for web separately, you do it for native separately, and then everything works as it. So your actual purpose is solved. The user doesn't care, right? The user just cares about the actual biometrics happening behind the scenes, right? Now this web authentication, right? This thing needs a server implementation as well if you go to the APIs, right? So this is something extra that you need to do behind the scenes. All right. Next is state management. Of course, you need state management at some point in time in your apps. Now again, 3 types of states, right? In memory, persistent state, and if you want, you can save some secure data, at least for the native apps. For web, you don't have an option, right? Now, in memory state, it's like the runtime is just JavaScript and React and everything, right? So any state management library just works out of the box, right? You just use whatever you want, Redux, Zustand, any popular library. Then Expo provides this async storage. This is again a wrapper on top of the web local storage and the native storage API, right? So it gives you one universal API to save your data. So you just do Expo async storage dot get item dot set item, similar to your local storage API calls, right? And it the other version of this is Expo secure store, which is similar to Expo async storage, but then this is for any sensitive data that you want to store. And this basically uses your OS level keychain management or your Android key store, right, behind the scenes to encrypt your sensitive data and keep it on your device. Now again, because it's sensitive, it's not available on web. Web you can't do much, right, in terms of saving sensitive data. You can obfuscate, you can do all sorts of encryption, but it's not a foolproof way for web. So you have to manage that if you want to do that at all on the web side of things. All right, now talking about third-party libraries in general, right? Now all these libraries that we saw, these are provided by Expo only, okay? But then you can also use other third-party libraries. But then Expo itself has so many libraries available for you, so you will literally get a library for every use case. Okay. Now, speaking about our use case, right? We have a camera use case, a location use case for our ATM finder and other things, right? And then you need a map to show all the ATM locations or bank locations, right? So Expo provides all 3 libraries for this. And all of these are, 2 of these are web and native compatible, but the third library, Expo Maps API, it uses native maps for native OS level native maps implementation. On the website, you have to go with the iframe or a web version of whatever maps implementation. It may be iOS or it may be Apple or Google Maps, whatever you prefer. But then again, that's a separate handling that you need to do, right? And if you look at a very simple example of how the Expo camera is implemented, it's similar to an NPM package, right? So if you see on line number 1, you just get the actual React component of the camera, and then you get a standard hook to grant permissions, right? So this hook takes care of the actual permissions of Expo. If when you open the app, it tells you, right, if you want to give access to the camera. So this is where you ask permissions. And then on line number 7, based on if your permissions are granted, you just render the actual camera view on line number 18. That's it. Right? And then the message that you get, right, when the app actually requests for permission, even that can be customized at this level. So if you are using Expo based workflow, you get an app.json at the root level, and then you just customize the string however you want, right? Now, if you weren't using an Expo based workflow, you might have to do that in the actual iOS and Android file systems, right? So you have to go to your info.plist file for iOS. You have to deal with Android XML files, configuration files to set the same setup. So that's why people generally prefer Expo related SDKs or whatever libraries which are compatible with Expo. Even there are third-party libraries. If you go to the documentation, they'll say that it's compatible with Expo. What it means is you don't have to touch the native code. It will handle it via this plugins. If you see line number 3, this is a plugin which handles your native part behind the scenes, right? So every third-party Expo library will have these plugins if at all things are needed to be changed on local, right? Yeah, and this is just a very short list of popular libraries available. Now, not all libraries need to be universal, right? There are specific libraries for native, specific libraries for web. So whenever you browse a library, it will show you tags. What support is there? What available support is there, right? Okay. Now, speaking about native modules, now, as I said earlier, right, there might be use cases where you have to manually write some iOS code, Swift code, or Kotlin code in order to get your problem solved, right? So in that case, if you are using an Expo app, you want both things to work fine, right? Now in that case, you actually opt for native modules. So what native modules is, it's kind of a framework which Expo provides separately, okay? And then using this framework, you can create an abstraction on top of your native implementation and then use that abstraction in Expo, right? So it's a similar pattern. The way you use Expo camera, what is that being done? Like it's an abstraction on top of native implementation, right? So Expo has been using its own native modules framework and building all these libraries for you, right? But it has also exposed this publicly so that you can build your own and not get bogged down because of just one use case not working for your universal setup, right? So it's pretty handy. We have tried creating native modules and it's working flawlessly. I mean, there's no, it's being matured from a long time. So you see, I think it's Expo 51, if I'm not wrong, that's the Expo version 51 running now. So it has matured a lot. All right, API clients. Again, you can use anything. It's a JavaScript based runtime environment. It doesn't really, it's a non-issue basically, right? Then you have environment configuration. Now, speaking of universal apps, right, there'll be certain environment related configurations specific to mobile, specific to web, and there'll be certain variables that you share across, right? Now, what Expo gives you is, for native side of things, right, it gives you something called as build profiles, by which you can actually categorize your build, that this actual build is for local, this is a production ready build which is signed by Apple certificates or Android certificates, and I can actually distribute it somewhere, right? So you can literally do a JSON based configuration, which otherwise you would have to do some manual stuff, right? So this is the wrapper that Expo provides. And then for web, we just have your similar to what you do for Webpack, right? When you deploy apps for different environments, Expo uses Metro configuration instead of Webpack, but you can switch to Webpack anytime you want, right? So it's pretty similar. Your .env variables work. Your anytime any build time or runtime configuration that you want to add, that works as is. Right, so build time variables you can use .env. Runtime variables, there is no official support. It's like it's runtime, right? You just pull it from your services and just read it and then change your app based on your behavior. And then you also have Expo Secrets, which is kind of a paid service. It comes along with when you want to deploy your applications to Play Store, App Store, right? So if you are building your application on Expo Cloud, and then you want to replace secrets while you're building the app, so you use the Expo Secret Manager directly. But then this only supports native, because Expo itself doesn't give you any hosting for web side of things. It's just for native apps, right? All right, so that covers our functional essential aspects. Now we'll quickly go to the non-functional side of things, but then we'll not cover everything because it's like every topic is like on its own, right? We'll just cover the specific ones, okay? Now, for non-functional thing, the first thing that you need is your deployment pipelines, right? Be it web or be it native apps. So you need to create deployment pipelines for publishing your apps to Play Store, App Store, publishing them to a test-based environment where people, developers, testers can download stuff and test it, right, in your actual production workflow. And then you have web pipelines as well for deployment, right? So this is where the Expo application services come into play. This is again what I said, right? It's a paid service. It's a freemium service. That's what they call it, right? So it's free till a point, but then after that, if you are doing a production level or a business level application, right, you have to pay. So it gives you Expo cloud servers where you can build your iOS and Android apps. It gives you a submit feature, where submit service where you don't have to log into Play Store and App Store in order to submit your apps. You can just rely on Expo and tell it to submit, because if you folks have done it already, right, it's a cumbersome process of releasing your apps to Play Store, App Store. There are a lot of configurations that you need to do otherwise. And then finally, this is a very interesting feature, which is the third EAS update, right? Now, what happens is, since we are running on a JavaScript runtime, right, Expo is able to push updates to your apps without even deploying without even publishing your apps to Play Store and App Store. You can directly push updates like you use it for web-based apps, right? There is no review. It works most of the time. Generally, people use this for pushing minor bug fixes or small updates, but then it works flawlessly. Now, the way Expo charges you is the number of devices that get updated on a single shot, right? So the charging or the subscription is based on that, and it has a limit on how many people will get this update over time. So it's a bit tricky thing to do, but it's still handy. People use it. So if you want to, you can actually go and explore this, right? And web side of things, again, Expo does not provide anything on the website. You still get a JavaScript bundle, which we all know how to handle, right? So it's just a JavaScript build. You deploy it wherever you want. You can use a hosting platform or deploy it on your own infrastructure, right? All right, next is performance. Now, for performance, we need two things, right? One is the performance monitoring, and one is how do you debug in case you have any issues, okay? So for debugging, you have certain Expo debug tools available. You have the Expo performance panel, which just shows up within the app itself, right, where you can see the CPU and RAM usage and other things inside, right? Then, because this is a JavaScript runtime environment, you can hook up the Chrome developer console to your native app's runtime environment and then just look at all the statistics there. So you have abilities to do that. Then you have a JavaScript profiler as well, similar to your web. Because it's a JavaScript runtime environment, you can actually just go and debug it like a normal web application. And then on the monitoring side, ideally, if you want to monitor what's happening on real devices, right, you need to use platforms like Sentry or Bugsnag, right? These are like actual third-party platforms which give you SDKs. You just install them, and then they'll give you a real-time view of what's happening with your native apps on actual users' devices. Even for web, you get a real-time matrix. They monitor performance. They give you crash reports, error logs, etc. So it's like you are literally remotely looking at real users' actual activity, right, and seeing what's happening. So if there are any issues or errors, you literally get those consoles right into the dashboard, and it's pretty much easy for you to, figure out stuff. So this is kind of a production standard. People use that all the time, right? So this is a very simple screenshot of the developer menu, which shows up on the actual native app. So if you shake the app, or if you put some command line combination, the developer menu shows up, and then you can just choose the JavaScript debugger or the Chrome profiler or the performance monitor. Yeah, crashes and errors we discussed, right? So there's Sentry, there's Bugsnag, there are all other platforms as well, but these two are the most popular. And the reason for adding these is, the best part is they work for both mobile and web. So you can just do one account. You can just look at the analytics of your web and native apps under one dashboard. Now the way you implement this is they provide you separate SDKs for native and web. Okay, so you have to implement and initialize those SDKs separately, okay, within your app. But then it works. I mean, the metrics that it shows, you can just use it like Splunk or something. It's just a query that you figure out. Right, and then security. Again, security-wise, each platform for its own. Native app-related security, you have to handle it separately. Web-related, you have to handle it separately, right? For native, you have this SSL pinning, secure data storage, and then code obfuscation, right? Now I've highlighted that because Expo gives you a very easy way to enable, disable this code obfuscation, right? Otherwise, you have to again touch the native code. Otherwise, so that's pretty handy. And web again, follow all the security standards. That's it. I mean, Expo doesn't have any opinion on this one. Right, and then finally accessibility. Now this is again one of the critical pieces which is taken as an afterthought, right? But then since you are doing universal apps, this might bite you later in the game where you are about to go live, and then it's just accessibility compatibility which you have to deal with. It's anyways difficult to make one platform compatible with accessibility standards. Now, because you are using universal apps, you have to make sure things work fine, right, in all platforms, because you just have single code base. Now, the universal library that you choose mostly takes care of this, but then when you build your screens, right, it's a combination of things that you do. So you will end up writing workarounds. That's our experience. Like, however is your UX, right? You have to, based on the type of UX that's rendered, you have to make sure that things are compatible when they are read through screen readers or keyboard support services. Now, for native, right, you use voiceover and talkback just to test what's happening. And then for web, you have JAWS and NVIDIA, right, for your accessibility testing. Now, one thing to highlight here is for accessibility, you can opt for choosing a separate view in case your accessibility mode is on for a device, right? So that's what generally people follow. So the UX or the layout is designed in a way wherein if a normal user is using it, you get a separate UI. And if an accessible user is using it, you can't show animations or you can't show fancy stuff to them, right? It has to follow the voiceover and talkback things. So you just change the UI when the accessibility mode is on, and that you can easily understand from the native app or the web app. It's a part of the configuration. So generally people follow that view, but then you have to talk with your whatever design team or people to, and then get this approved from the business as well. All right. The last part, which is challenges and factors, right? Some of the important challenges that we have added, I mean, these are not the only challenges you would face, but then these are one of the most significant ones that might arise. Now, depending on your use case, you might feel a jankiness based on the animation or the calculation or the logic that you have written. You might find some stuttering happening between views. And it would depend on different devices as well. Like if it's a low powered device, you will see it immediately, right? So you have to optimize for that. But then this is why we want to do a proper POC before you move to choosing this universal app, right? This is one of the factors to consider. So if your app is like very much performance intensive and there are a lot of animations, though the ecosystem has very nicely evolved, you would see very nice third-party libraries which can be used and which give you a 60 FPS native like animation, just like how it should work on iOS, Android and web. But then still, it's better to get your homework done before you choose to build this app, right? Then there is library compatibility. As I said, right, we might end up having a scenario where you don't have a library and you have to write on your own. So even if you use the Expo module to write your own use case, you have to yourself maintain it and then make sure things are working fine as the version progresses ahead, right? And that's the third challenge, which is you are using Expo. Expo is built on top of React Native. React Native follows React ecosystem. right? And then I think because these are all major libraries, they have updates every 6 months rolled out, right? So you have to be very much compatible and up to date. You have to put those updates in your actual sprints and then get them done as your tech debts or whatever you want to call it, right? So you will end up chasing a lot of updates along with your actual development. So, and this is again, I mean, people might say this might be optional, but then it will screw up with your app once you go live, and then if you just don't do anything, right? The next feature you add, things will start breaking. So this is also important, and this becomes complicated now because now you have to handle web updates, native updates from a single code base, right? So even if web's not working, the native bundling might fail for some reason, and you have to just spend time doing stuff, right? And then finally, these are some extra factors to consider when you are choosing the universal app, right? So first of all is the type of team you are working with. If you don't have native developers, then this is one of the factors, right? People choose that, okay, we have a web team, let's build a native app, let's use this framework, right? Now, it's not the only factor. This is one of the factors to consider, okay? It should not be the deciding factor, okay? Then you have the budget, which is again an additional factor depending on how big is your team, how many people you can recruit, how many people you can keep over time to maintain these code bases. So it's a big decision. It's again a business decision, right? And then finally your app requirements. This should be one of your primary factors. So if you think your app suits the use case, right, and it's pretty easy to build these screens across native and web, so you can just do a very quick POC and then go ahead with it. Yeah, and that's it for the talk. Yeah, so we have a demo app created. Anish helped create the demo application. So just try it out, scan the QR code, set up the source code on your local machines, give it a try, and let us know how it goes. There are some dummy features added, but then at least you should be able to see the implementation. All right, has everyone taken this? Cool. Time for Q&A. We'll spend the next 5-10 minutes. Yes?
You mentioned some of those components are not compatible with web, like the map one, the SDK.
Yeah.
So then what happens? Like, how do you handle that then? So you got to use.
So we can actually, so Expo gives you a way to render different components based on the platform.
Based on the platform.
Right, so you just write a web implementation of that Maps API, and then since on the web side of things, I think you can just ignore to build that native side. Like you can configure your Webpack or Metro configuration and then just
Expo has a basic file-based naming convention. So if file.web.ts is just rendered on the web.
Okay.
So there are a couple of layers where you can do. So one of the files in the demo follows that. There is a component which is in two periods, one for the web and for native.
And testing. Did you mention testing?
no, it's a topic on its own, so we thought of, but yeah, we can discuss if you want.
So is there anything, so what can we use for like testing? What frameworks can we use?
See, testing, there are levels, right? There is unit testing, integration, there is automation. Now automation you can't escape. You need to have a native, separate automation for native, separate automation for web. For unit and integration, it's just like the way you test your JavaScript apps, right?
Okay.
That's it. You have a virtual, it's generally Zest. It gives you the whole, there is a Zest native package. So it gives you a runtime for your native app as well as web app, and you just write tests like normal. Yep.
I have a question on pricing. So all that information that you provided here is if we use Expo as a framework. Does it have a pricing attached to it, licensing attached to it?
Yes and no. So basically the way Expo, so it's an ecosystem, right? So it gives you command line tools which are free to the point where you are not deploying to their servers. So it gives you this Expo Go app and Expo Dev Client, all the libraries that you saw, right? Everything is free. The code is free. But then as long as you stay within that boundaries, right? And then if you want to use their infra, if you want to use their push services, credential management service, push notification service, those things you have to pay. And the payment also varies. So they have a pay as you go model, which you can opt for if that fits you. They have a subscription based model, so you just pay flat rate regardless of whatever you do with their services. So you can tailor the plan according to you. We did a Expo app for a client. It was a native implementation, but then we never used any Expo service. We just used their Expo framework, their libraries, their command line tools, and you still have to create an account in the Expo dashboard for, that's only required because you don't have to spin up multiple projects for multiple developers, right? Every developer should have access to the same project. So for that, just once you have to log in, but then it doesn't ask you for any payment unless you fire a wrong command and then push stuff to their cloud for building. Yeah.
So that Expo Go app you said, that's free.
That's free. Yeah.
So you can always test your app.
Yeah. You can set up this code on your local machine, just scan the QR code and you should see the app directly on your phone. Cool. Any more questions? All right. Awesome. Oh, sorry.
I'm asking EAS update, is it the same with the Compush?
I'm not really sure. I haven't made a comparison, but it might be. Yeah, it might be. It has. But Expo has its own mechanism to push stuff. So the purpose might be same, but the implementation might be different. Yeah.
So how do you usually manage the version control?
Yes.
Hotfix one?
Hotfix. Yeah. Again, Expo doesn't dictate how you should manage your versions, but it can keep your version history and then update the version. And if you don't update your version in the code, it will just throw an error while build time. So all those things it does for you. But version management is totally up to you, however you want to set up, right? Major, minor, patch fix, or whatever semver versioning that you use. It's totally up to you. Web, we don't care, right? Web is like just push stuff, that's it. Yeah. Okay, all right. I think that's it.
I have a question.
Oh yes.
How do you manage labels for accessibility?
Labels for accessibility, yes.
With the automation and accessibility, sometimes use the same label. So how do you manage it?
Yeah, so it depends on what automation you are using and what accessibility label you have added. Whatever universal library that you pick, right? The components that you use, it has some accessible APIs, right? So you need to add two separate labels, one for native and one for web, and then you have to add a third label or a third test ID or whatever identifier which your automation can use, right? And it really depends on your philosophy. So if you're familiar with this React testing library, right? So it always says that find your components using your accessible elements, like the way user sees it, right? You don't have to put test IDs and everything. So you can follow a similar concept in automation, whatever framework you choose, right? Maybe you choose Cypress or you choose APM. So if the element is accessible via a label, just pick it up from there. If not, worst case scenario, put a test ID, get that label in. And as far as the labels for accessibility are concerned, as I said, right, like you have to really go through the documentation to understand how this component requires labels for web and for native. For example, if you use a radio button, right? A radio button for web is different from the one which is there for native, right? So the label callout might be the same, but you might have to add two props, separate props while setting up that label. There might be components which just accept one label and they'll figure out internally what needs to be done. So it really depends on the framework that you choose and what type of label you are using. Yeah. Cool. All right. that's it then. Cool. Thank you everyone once again. I'll hand it over to Yanmei for some announcements. Thank you.
Hi everyone, I have met all of you earlier. My name is Yanmei. I lead the HR operations function at the Fabric Group. So for someone who hasn't know much about Fabric Group, I would suggest you to follow us on LinkedIn to know more about like what we are doing, how we're working, and also for some other opportunities. And it's our pleasure to know like what's the topic for the next pickup, because we are not only we have more talent people in-house focusing on front-end UI, UX design, business analyst, delivery, and the testing for somebody who asked for QA testing, and some other areas. So it would be really great that we can see your feedback and we can work on more to provide more opportunities for meetups so that we can share more knowledge. Normally, this session is run up by our talent acquisition specialist, Eva, who has already known about, because currently she's working offshore remotely. So I'm doing this part of presentation on her behalf. So at the Fabric, I would like to quickly share the openings we are currently have. First is a full stack developer. The second one is delivery lead. And the third one is the application support engineer. I wouldn't take more time because it has already been a long session, but please do follow Eva on LinkedIn to find out more about the JDs, what are the expectations like locations of work, because Fabric has operations onshore here in Australia, but we also have offshore team in Singapore, in India, in China. So feel free to follow Eva and to follow us for opportunities to know more about Fabric Group. And again, thank you very much for your coming today. And the next is the free chat session.